Okay, this is the electron unit, and light is a wave. So this is a lot of definitions. So you just need to make sure that you write them down correctly. All right, first one is light. All right, and light is a form of electromagnetic radiation. Okay, and it has characteristics of both waves and particles. Okay, characteristics of both waves and particles. All right, so we're going to draw a wave here. All right, and then we're going to label its parts. So you got your origin right there. Okay, right where the x and the y-axis meet, and you've got your wave. Okay, that line right there from the origin to the top of the wave is called your amplitude. Okay, from the origin to the top of the wave is called the amplitude. The top of the wave is actually called the crest, and the bottom of the wave is called the trough, like a horse trough, like you would see at a farm. Okay, now a wavelength is from one spot on a wave to the identical spot on the next wave. So here, the easiest thing to do is to go from one crest to the next crest. And that's one wavelength. You could do it at any point as long as it's in the same direction. It's essentially the identical spot on the next one. Okay? So more definitions. We've got wavelength. Okay, and the symbol for wavelength looks like an upside down Y. And this is the shortest distance between two equivalent points on a wave. All right, shortest distance between two equivalent points on a wave, and it's measured in meters and millimeters and nanometers, just depending on what kind of wave it is and how big it is. Next two definitions. Crest is the top of the wave, and the trough is the bottom of the wave, just like we saw up there. Nothing too difficult about it, just, kind of is what it is there. Next one is frequency. Frequency looks like an italicized V, or if you're not very good at art, like a bird in the distance, okay, like a flying bird. And the frequency is the number of waves that pass through a certain point in a given amount of time. Okay? Number of waves that pass through a certain point in a given amount of time. So if you have a lot of waves moving through very quickly, you have a high frequency. And if they're very slow moving, you have a low frequency. Okay? Next term is hertz. And hertz is just the SI unit for frequency. Okay? It's 1 wave per second or 1 per second. Okay? 1 per second or 1 wave per second. So if you said it's, 15,000 waves per second or 15,000 per second, that's hertz. Okay? 15,000 hertz is what that is. Next one is amplitude. Okay? And this is the wave's height from the origin to the top of the crest or to the bottom of the trough. Okay, from the top of the crest or to the bottom of the trough. Either way, but as long as you're starting at the origin, that's the key point. All right, and then next definition, you've got wavelength, and then you've got frequency there, and those do not impact amplitude whatsoever. Okay, they do not affect amplitude at all. Okay, so those are our definitions. All right, so now let's talk about how light travels in a vacuum. Okay, all electromagnetic waves, all of them. Doesn't matter their size, amplitude, none of that. Okay, all electromagnetic waves travel at the speed of light in a vacuum. in a vacuum. Okay, and that number is 3.00 times 10 to the 8th meters per second. Okay, the symbol for the speed of light is just a c. Okay, the letter C. Okay, now the I'm sure you've heard of E equals mc squared, just even in random, I'm sure you've heard it somewhere. The C there is the speed of light. Okay, so the equation that we're concerned with is the speed of light equals the wavelength times the frequency. Okay, the wavelength times the frequency. So if frequency equals 3.44 times 10 to the 9th hertz, okay, what is the wavelength? Okay, we already have C right there. It's the speed of light. Okay, so over here, C equals wavelength times frequency. Okay, so 3.00 times 10 to the 8th equals, messed up my screen there for a second. 0.00 times 10 to the 8th equals the wavelength times the frequency, which was 3.44 times 10 to the 9th. Okay? Divide by 3.44 times 10 to the 9th. Okay, it's basic algebra. Right? That divides out, and you're left with the wavelength is 0.0872 meters. Okay? Now, it's got to be in meters because speed of light is meters per second. Okay? And hertz is 1 per second. Okay? If you remember from the definition. So this has to be meters. Okay? All right, and basic algebra with this, to where I ask you what frequency is, or I ask you what wavelength is. There's not a whole lot that I could ask you. We're going to be dealing with only with stuff that's in a vacuum. So C is always going to equal 3.00 times 10 to the 8th. All right, just some basic math there. So that is light as a wave.